So in your previous class, we have discussed about static routing. Like before that, we discussed IP routing. So what is IP routing and conditions for IP routing and types of IP routing and static routing we have seen. So actually, IP routing is the process of moving IP traffic from one network to another network. So when traffic is moving from one LAN to another LAN, it involves two basic activities: finding best path, forwarding packets, forwarding traffic through best paths. The conditions what we have discussed in IP routing is four fundamental conditions. Like here, branch one head office. If branch one head office example, so router LAN interface IP address and LAN users IP address should be in same network. For example, 10.0.0.1, then end user should be in same, like 10.2, 10.3. So second condition is head office and branch office one. Serial IP interface between head office and branch office should be in same network, like branch one serial port IP address, head office serial IP address, both should be in same network address. So here 1.1.1.1, 1.1.1.2. Condition number 3, head office LAN, branch 1 LAN should be in different network. So head office LAN I have used standard network, and branch office LAN, can I use again 10 dot network here? No. So it should be different. So branch 1 I'm using here 192.168.1.1, 1.2, 1.3. Network is 1.0. The condition number 4, all interface of router should be in different network. So branch 1, 2 interfaces, LAN and WAN. So for LAN interface, I have used 192.168. For WAN, 1.1. Same like head office also, all interface should be in different network. These are the basic conditions we have seen. And static routing types. Sorry, uh, IP routing types: static routing, dynamic routing, and default routing. So static routes are configured, maintained, updated by network administrator manually. And to configure static routing, we should know destination at networks. And administrator distance is 1. So we clearly see in like every router maintains a routing table. Like by default, routing table is empty. By assigning IP address to LAN ports and by activating the LAN port, and you can get update in the routing table. So routing table contains directly connected networks. And destinations are we need to be updated manually. So how to update it, how to configure static routing, and how to verification. These things we have seen yesterday clearly, right? So do you have any doubts in static routing? Yes. Any doubts, guys?
No, Bal.
Okay. So before dynamic routing protocol, I'll tell you one very important scenario here. See, my scenario is I have office, name is ABC. In my office has some departments. Okay, sales department, HR department, marketing department, like ID department, 4 departments. So sales department, there are 50 devices. Even HR department also, marketing department, and IT department, 50 devices. So here, my simple question is, how many devices in Office ABC total?
200.
200 hosts, right? Yeah. Now, to enable communication between these all 200 hosts, we have to assign IP address. So which class IP address do you recommend to use for Office ABC? Class A, or Class B, or Class C? Which class IP address do you recommend?
B.
Class?
Class B.
See, Office ABC requirement is how many hosts? 200 hosts, means 200 IP address I need. See, if I use Class A example, for each network of Class A, we have 16 million IP addresses. So like 16 triple 7 216 actually, but two IPs have been minused, network ID and broadcast ID. So 214. The requirement is 200 hosts only. For 200 hosts, if I use Class A, there will be 16 millions of IP addresses being wasted. So Class A is not recommended. Similarly, Class B, if you use Class B, per each network of Class B, we have 65,534 IP addresses, but Office ABC requirement is only 200. Even if it's a Class B, also again 65,000 plus IPs are been will be remaining waste. So Class B is also not recommended. So finally, which class is recommended? Class A, per each network of Class A, how many IPs are there? 254. So Class C is recommended. The Class C networks, example 192.168.1.0 is network ID. 192.168.1.255 is a broadcast ID. In between all IP addresses, we can make use. So I have started to assign for sales department from 192.168.1.1 to 192.168.1.50 for HR department 192.168.1.51 to 192.168.1.100. Similarly, marketing department 192.168.1.101 192.168.1.150. IT department 19168.1.151 to 1.200 have used. Clear? Yeah. Now, all departments are being assigned IP address. Now you tell me guys, sales department, HR, marketing, IT, all departments can communicate each other? Yes, they can. Why?
Yes, because they are in same network.
Because they are in all are in same network, right? Yes, right, Anil. Prashant. So now my requirement is sales department should not communicate to HR. So HR should not communicate to marketing. Marketing should not communicate to IT. Like inter-department communication should not be there. That is my requirement. And what is the solution? So present all devices can communicate because of all are in same network. But my requirement should not communicate. Then what is the solution?
VLAN.
No.
Subnetting.
Okay.
So we separate all these departments in different network.
That's good. See, now all departments can communicate each other because of all are in same network. My requirement is what? Should not communicate. Then make them into different networks. They don't communicate now. We'll do that thing. So let we keep 1.1 IP address to 1.50 for sales department. For HR department, let me use 2.1 to 2.50. Like ID department, sorry, marketing department, 3.1 to 3.50. For ID, 4.1 to 4.50. So like I have assigned IP address to each department. Now will they communicate each other?
No,
No, they don't communicate. Why?
different networks.
They're in the different networks. They don't communicate. So that is what my requirement actually. So my requirement has been satisfied here. So entire department communication should not be there. Then I have assigned different networks. They have used different networks. They don't communicate. So my requirement is okay. But problem is each network 1.1 to 1.50. Actually, class C per each network, how many IP addresses is there? 254 IP address. Like out of 254, how many IPs are being used for sales department? 1.1 to 1.50 only. Remaining how many IPs are being wasted?
200.
Like remaining 200 plus IPs are being wasted. For second HR department, again 200 plus IP address. Here 200 plus IP address. Here 200
200.
plus IP address. Like total for four departments, how many IPs have been wasted?
800.
800 plus IPs have been wasted for four departments. Even if it is a class E also, we are wasting 800 plus IP address. So actually, IPv4 address is 4.3 billion IP addresses being divided into classes. Class E, we are not making use R&D. Class D, multicast. So we are using which class IP addresses? Class A, Class B, Class A only. So from Class A, Class B, Class A also again 0.0.0 is global ID. We are not making use. And 127.0.0 is loopback ID. Network IDs are minused. Broadcasts are minused. So remaining IP addresses only we need to be survive in the globally. See when IPv4 is being developed, so at the time internet users are very few users, like 10,000 users only internet users. Then what developer will thinking? Yeah, present internet users are 10,000 only. So we have developed 4.3 billion IP addresses. Maybe in coming 30 years, 20 years, also there is no problem with IPv4. So because of we have developed very huge IP addresses. Like that developer is thinking actually. But what happened? So within a short time, like your technology is evolving very high potential, you know. So how many countries, how many equipments, how many devices, how many users, how many what is the internet usage nowadays? So there are so many technologies on so many devices in there. So every device required a IP address. So we are running out of IPv4 addresses. And 1990 itself, then IPv6 has been started 1996, 1990. But still, Even in 2021 also, still we are surviving with IPv4 only. How it's possible? So because of only one solution is, so for 4 departments, what is the requirement? 4 departments should not communicate. So for that, we have used different networks. So if you use a different network, your requirement is satisfied. But problem is what here? 800 plus IPs have been wastage. So this wastage of IP address, if we minimize, if we reduce that, then we can survive with IPv4. So that is the main concept is how we can minimize the wastage of IP address. How we can minimize wastage of IP address. What's the best solution here? Best one and better one.
For one apple, we have to make it 4 pieces.
Exactly. Like don't get the 4 different apples. That take only one apple and make into 4 parts. Then use for Pradeep 1 piece, Anand 1 piece, and Das and Naveen 1 piece. So we don't have any wastage here. Similarly, same example. So our requirement is here. Sales department, HR, marketing, IT should not communicate. For that, we have used 1 dot network, 2 dot network, 3 dot network, 4 dot network, 4 different networks. So instead of 4 different networks, we can use only one network and we can divide into 4 parts. No wastage of IP address. So if I use 4 different networks, then we have 800 plus IPs in wastage. So instead of going the 4 different networks, we'll use only one network and divide into 4 parts. So each part we can use for sales department, HR department, marketing department, and IT department. Then no wastage of IP address. So dividing from one parent network to multiple child networks, or one major network to one smaller networks. So creating multiple independent networks from a single network, this process we called what? Subnetting. So based up of subnetting only, still we can survive with IPv4 addresses. So service providers will do what? Subnetting. Because of lot of customers are connected. So each customer, they cannot provide one network, right? So what service providers will do? They use one network and divide into multiple smaller parts. What is the possibility, minimum possibility and maximum possibility they can customize and go to customers. So here, two major questions, guys. One is, what is subnetting and why subnetting? Can anyone please answer? What is subnetting means what? Yes. What is subnetting? Dividing single network into multiple smaller networks is subnetting. So why we are dividing like this? Why subnetting is required? To minimize the wastage of IP address. Yeah. So two major questions, even if you go for interviews also. So what is subnetting and why subnetting? Right. So subnetting is creating multiple independent networks from a single network. So you take one single network. If your Office ABC requirement is there are 4 departments, then make them into 4 parts. So each part you can use for each department. If your Office XYZ requirement is there are 10 departments, then don't go with the 10 different networks. Use one network and divide into 10 different parts. So we can take one network and based upon a requirement, we can customize to maximum. So one network. So we are creating multiple independent, like multiple different networks from a single network. A single network can be class A network or class B network or class C network. From single network, we can divide into multiple different networks. So this process we call what? Subnetting. So how we can divide single network from single network to multiple different network means the logical is converting host bits into network bits. So if class A 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, like host bits, right? So these host bits, converting host bits into network bits, even for class B also, class C also. That process we call subnetting. So subnetting can be performed in the two ways. One is FLSM subnetting and VLSM subnetting. Fixed length subnet mask and variable length subnet mask. The main point is subnetting can done based upon requirement. Based upon requirement, guys. Based upon what requirement? Number of networks required, number of hosts required, Cisco slash notation requirement. Like entire subnetting can be done based upon requirement. So in your office, if a requirement is the networks required, so we'll go subnetting based upon the network requirement. No, you have a host, like you have a devices is there, like host requirement and Cisco slash notation requirement. So this subnetting is very, very useful for service provider type of networks. The large companies, the large organizations. As a note here, it is very useful for service provider, internet service provider, and large companies and large organizations. So today we'll try to discuss clearly on based on requirement in point number 1, number of networks required, point number 2, number of hosts required, point number 3, Cisco slash notation requirement. Okay, right. The first point is number of networks required. Number of networks requirement. So how to do this calculation means 2 power n. 2 power n greater than or equal to requirement. This formula how to use. It should be greater than or should be equal to. 2 power n greater than or equal to requirement. Says number of networks required. Now let me take 2 power n values. So 2 power n can be 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, 7. Any power 0, it's 1, it's 2, 4, 8, 16, 32, 64, right? 2 power 6 is a 64 and 128. Now let me continue with based upon our Office ABC example. So what we need to do now? When you take a different networks or we take a one network into different parts. So let's take one major network and convert it into different parts. Like how to do that? So example, I'm taking one network. Network is the base example 1.0. 1.0 is network ID 192.168. One dot. What is the broadcast ID? 1.255. So broadcast ID is a 1.255. So now what we call in between IP addresses, network ID and broadcast ID, in between all IP addresses, what we call valid IP addresses. Like how many valid IP addresses there? 254 valid IP addresses available. Then what will be the subnet mask of all 54 IP addresses? 255.255.255.0 is the subnet mask. So here we have four parameters, guys. Network ID, broadcast ID, valid IP address, and subnet mask. So this is one network. This is one single network. This is one parent network. This is one major network. So we are using this network, and based upon your requirement, we can make them into four parts. We can make them into two parts. We can make them into like 8 parts. We can then make them into 16 parts, like this. Based upon your office requirement, we can customize one network into from this network, we can create multiple subnetworks. So like Office ABC here, how many departments is in Office ABC? So for sales department required one, HR department required one subnet, marketing and IT. So here our requirement is a 4 subnets. Then make them into 4 parts. So if we divide into 4 parts, then each part, each block we called subnetwork. It is not a network. It is not a network now. It's a subnetwork. In short form, we call subnet. So one network is divided into how many subnets? 4 subnets. Is the first subnet. So first subnet, second subnet, third subnet, and fourth subnet. 4 subnets is divided. Now again for each subnet, there will be network ID, broadcast ID, valid IP addresses, and subnet mask. Same for second subnet also, third subnet also, fourth subnet also. If it's not subnetted, then we'll say what is the network ID? 1.0, broadcast ID 1.55, valid IP addresses 254, subnet mask 255.255.255.0. This is one major network, we know clearly. But one network is divided into smaller parts, 4 subnets. Now for each subnet again we need to find out network ID, broadcast ID, valid IP address, and subnet mask. Clear? All of you are following me?
Yes.
Yes, sir.
Okay. Yeah. So we'll do this thing. So now number of networks requirement, we'll take example of Office ABC requirement only. So Office ABC requirement is, how many subnets Office ABC required? 4, because of 4 departments is there. So Office ABC requirement is 4. Now what is the formula we have to use? 2
2 power
power
n.
n greater than or equal to requirement. So 2 power n greater than or equal to, what is the requirement? Requirement is 4. Requirement is 4. So based upon my requirement 4, then what n value will be satisfied? So your 2 power n, it should be greater than or should be equal to for your requirement. So 2 power 0 can be satisfied? No. 2 power 1 can satisfy? No. It should be greater than or should be equal to. So 2 power 2 is equal. Like let me take 2 power 2. So 2 to the power of 2 greater than or equal to requirement. So 2 power 2 is what? 4. What is 4? So one network divided into 4 subnets. That is 4 here actually. So 4 subnets, subnetworks, and short form we call subnets. It's done. Now we have used the base network is 192.168.1.0, right? It's a Class C network. What is the subnet mask of this IP address? default. Subnet mask is 255.255.255.0. So try to write this 255.255.255.0 in binary long ways. 1, 2, 3, 4, 5, 6, 7, 8 dot. Yes, and zeros. 1, 2, 3, 4, 5, 6, 7, 8. This is the binary long ways, right? Yeah. Now tell me guys, what is subnetting? So subnetting means converting host bits into network bits. So converting zeros into what? Ones. So zeros into converting to ones. Like how to convert? Like your host bits we need to convert into network bits. Like how many host bits, how many network bits you need to convert it bits upon depends upon always your 2 power value. So 2 power value is what means n value is what 2. N value is 2, then convert 2 bits from left to right. Okay. My God. Yeah, let me write here subnet mask. So subnet mask is 255.255.25.0 binary 1, 2, 3, 4, 5, 6, 7, 8. All right. So how many bits need to be converted into network bits? How many host bits to convert network bits depends upon your power value. So power value is what here 2. Then convert 2 bits. So first bit and second bit have converted. So what is the first bit value? 128. Second bit is what? 64. So now we have one more subnet mask will come. What is that? 255.255.255. 128 plus 64.
92.
192. So these subnet masks we call customized. Based on our requirement, we customized. Before subnetting, what are the subnet masks we have? That subnet mask we call DSM, default subnet mask. Like after subnetting, we have subnet mask. This we call CSM, customize subnet mask. Okay. Yeah, subnet mask is done. Now let's say for each network, I mean for each subnetwork, how many IP addresses will come? If it's a parent network, if it's a major network, like total 1.0 to 1.255, in between we have 254 IP address. But one network is divided into 4 subnets. For each subnet, how many IP address is there? Let me see. So for that, we have to use formula is power number of host bits minus 2 to power number of host bits minus 2. So to power number of host bits, like first octet all are network bits, second octet network bits, third octet network bits. In fourth octet, first two are converted. So here question is, remaining how many host bits are there? That is the point. So remaining host bits, number of host bits are 6. So 2 power 6 minus 2. 2 power 6 is 64.
64.
Yeah. 64 minus 2, 62. Valid. 62 are usable, right? 64 are total. Out of 64, 2 IPs are minus. Network ID and broadcasted. So 62 valid. What is valid? Valid
IP address.
host. Yeah, valid IP address for each. Yes, please. For each. For each subnet. So here we have 4 subnet. For each subnet, we have 62 valid IP addresses. Clear? So first subnet, there are 62s available. For second subnet, 62 IP addresses you can usable. Even third subnet, 62 usable address. Fourth subnet, 62 usable address. But what is the first subnet range? From where to where? Second subnet range, third subnet range, fourth subnet range. If you try to write the ranges, it's very, very simple to write the ranges here. Please focus. Now first you can use the base network. What is the base network? 1.0. That is your first subnet. 192.168.1.0 is your first subnet. I mean network ID. Now next network ID. So next network ID will be, we have converted 2 host bits into network bits, right? Which is 128.64. Like out of 2, which is the least converted bit? The least converted bit is what? 64, right? So 64 is a magic figure here. 64 is magic figure. Then you can keep adding on 192.168.1.64. So 64 is a magic figure. Again, 192.168.1 dot plus 64 means 128. Again add 164. 192, 168 dot 1 dot plus 128 plus 64, 192. Like you keep on adding it, 64, 64, 64, like until you got invalid or 4 times, means because of 4 subnets. 192, 168 dot 1 dot, if you add 64 again, we'll get 256. So 256 is valid? No. So to stop here. Okay. Yeah. Now, can you write, please, what will be the next, I mean, previous IP address before 256? What is the previous IP address? Before IP address? 192.168, 1.255. Before 192? 192.168.1.191.
191.
Yeah, before 128.
127.
So 192 dot
168.
dot 168 dot 1 dot
Dot
127.
27.
Exactly. Before 164 IP address.
192.168 dot
Yeah.
63.
63. Okay. Dot 168 dot 1 dot 63. So 256 is invalid. Let me remove it. So the left side we have, these all are network IDs. Left side are network IDs. You know, and the right side values are broadcast IDs. So we got the range now. Like 1.0 to 1.63 is a first subnet range. Is a first subnet range. And second subnet 1.64 to 1.127. Second subnet range. And it's a third subnet range and a fourth subnet range. Now this one network is divided into 4 independent networks. Now what I'm doing is 1.0 to 1.63 I used for sales department in my company. Like 1.64 to 1.127. 1.64 can we use it? 1.64 IP can we use? No. So 1.64 is the network ID. So 1.127 can we use? No, broadcast ID. Between the IP addresses we can use. Between how many IP addresses is 62 IP addresses, but my requirement is 50. The sales department required 50 only. So out of 62 you can use happily 50. So 1.65 to 1.126 IPs you can use for HR department in my office. 1.129 to 1.190 I can use for marketing department. No, the last network range I can use for IT department. So here we have used only one network and our requirement is also satisfied. So because now sales, HR, marketing, IT, will they communicate each other? No. Why? Because all are in different, what? Different?
Networks.
Different?
Networks.
Subnetworks.
Yes, different sub network. But
They're in different subnets. So here HR department, sales, marketing, IT, they are in different networks, like 1 dot network, 2 dot network, 3 dot network, 4 dot network. They're in the different network. They don't communicate. But IP, lot of IPs are wastage, 800 IP address. But here, sales, HR, marketing, IT, they're in different sub networks. They don't communicate again here. So we are not going for the different networks. We have used only 1.0 network and we divide into 4 different subnets and we allocate it to different departments. It's clear? So this is how in the real time we used to customize a network into smaller independent networks and we can use in your live environments.
Can we identify whether this IP address is in a subnetted IP address or not?
Yeah, based upon the subnet mask, we need to understand. If you use customized subnet mask, then it IP subnetted. If you use default subnet mask, it is not customized. It is not
Can you
subnetted.
put the subnet? Can you put the subnet for this network also?
Yes, every IP address there will be subnet mask. So by seeing the subnet mask, we can understand it is customized or it is not customized. I mean, it is subnetted or not subnetted.
For this example, will you put add the subnet also?
Which one?
For this example that you have told now, can you
Okay.
put add the subnet as well?
Yes, for all networks, means sales department, HR department, for these all the IP addresses have to use the subnet mask, 192 subnet mask. So we cannot use, we don't use this default subnet mask actually. Like sales department, first computer, IP address 192.168, 1.1 have assigned. Subnet mask is what now? 255.255.255.192 is a subnet mask here. So if you use the 192 subnet mask up to 62, means up to 1.62 IPs are in same subnet. From 1.65 comes in a different subnet. Okay. Yeah. You can copy it now.
Balu,
Yeah, please, Madhu.
these 4 subnets, even though one network only,
Network is
from
one,
my
but we
understanding,
customized
mask.
into 4 different. Masking, yeah, mask is same. Yes. For 4 subnets, mask is same,
Mhm.
192.
Okay.
Why? Because
Mm.
your department requirement. So sales department, how many IP addresses are usable? 62. HR
62.
department, 62.
62.
Marketing, 62. So one network is equally divided, right?
Yeah.
So this type of method of subnetting is FLSM. Subnet mask is fixed. Fixed length, subnet mask. So for
Mhm.
4 subnets, your subnet mask is fixed. 192 only.
Okay.
Where if your requirement, sales department requirement is a 100 IP address, HR department is a 50 IP addresses, marketing is a 20 IP addresses, IT is a 10 IP addresses. If requirement is a variable, different, then you have to go for VLSM type of subnetting as well. So we'll see in advance, like in CCNP level classes, like how to do that. So first we'll go with this basic FLSM subnetting. Okay. So in 4 subnets, subnet mask is same for all departments. Clear? Yeah. So let's consider this or stepwise. We can consider this is a first step and second step, third step, so fourth one, fourth step. I'll give one task for you. You try to do that based upon the same. Number of networks required 2 power n greater than or equal to requirement. Now Office ABC requirement is 30 subnets and base example is 192.168.5.0 is a base example. From this network, you divide into 30 parts, make them into 30 parts and tell me how many subnets we can get, what is the CSM, and for each subnet, how many usable addresses and network ID, broadcast IDs. And do it fast and tell me the answers. So requirement is now 30. So this example, 2 power n greater than or equal to, requirement is 30. So what n value will be satisfied here?
2 power 5.
5.
Plus to 5, yeah,
So 2 power 5 is what? 32.
32.
So possibility is 32 subnets will get, but the requirement is 30. Out of 32, you can use 30. No problem. 32 subnetworks. So class C,
Why we are used 2 raised to 5?
a requirement is 30, right?
Yeah.
Yeah. A requirement is 30, then you have to use 2 power 5. 2 power 5 is 32. So conversion 1, 2, 3, 4, 5, 6, 7, 8. Then how many bits need to be converted?
5 bits.
5 bits. Like 1, 2, 3, 4, 5 bits. So 128, 64, 32, 16, 8. What is the value you can get?
48.
148.
So 255.255.255.248 is a CSM, customized subnet mask. Now for each subnet, how many usable addresses you'll get? Raised to power number of host bits minus 2.
6.
So 2 power 3 minus 2. It's 8 minus 2. We'll get what? 6. What is 6?
Usable
Usable
IP address.
Exactly. So 6 valid host
IP
per
address host.
for each
Subnets.
for each subnet.
subnet. Perfect. Now how to write the ranges? What is the magic figure here?
8.
8 is a magic figure, right? So 192.168 5.8 192.168 5 dot plus 8 16
60.
192.168 5 dot plus 8
64.
24.
24.
Like this you keep on writing it. The last subnet range is 192.168 5 dot 2 5 dot
248.
248. The broadcast IDs are 192.168 5 dot 255 and here 192.168 dot 5 dot plus 8 means 32 means 31. So it's 192.168 5 dot 23 192.168 5 dot 15 and 5 dot 7. These are network ID and broadcast IDs. So first subnet, second subnet range, third subnet, fourth subnet, it's 32th subnet.
Bharu, here one question.
Yeah.
What would be the default gateway for these subnettings?
Yes. So here 5.0 is a network ID and 5.7 is a broadcast ID from first subnet range. So you can usable address are 5.1, 5.2, 5.3, 5.4, 5.5, 5.6 you can use. First one you can use the gateway address 5.1 for first subnet. In second subnet 5.9, 5.9 you can use a gateway like this. So each subnet we have one gateway. Okay. Yeah. So this is how we can customize based upon our network requirement. Let's see one more example based upon host requirement. Okay. Yeah. Now, number of host requirement will continue. Number of host requirement formula is 2 power h minus 2 greater than or equal to requirement. So 2 power h minus 2 greater than or equal to requirement you can use. Why minus 2? Network ID and broadcast ID. Now, Office ABC requirement is, let's consider 12 hosts. I needed 12 IP addresses in my network. So let me use a base example from this example. Okay, 10.0. So this network we need to customize to 1212 IP addresses. Clear? Right. The first step, 2 power h minus 2 greater than or equal to requirement is 12. Then what will the h value? Satisfied h value?
4.
2 power 4 is 2 power 4 minus 2. Our requirement is 12. So 2 power 4 is what? 16
16.
minus 2. What is 14?
Usable IPs.
14 valid usable IP addresses, valid host per subnet. A requirement is 12 IP address. So can we get exactly 12 IP addresses? No, possibility is 14. So from 14 you can use 12 IP address. 2 more extra, no problem. Like this. Okay. Yeah. Now see, customize a subnet mask. Like in number of networks calculation, number of networks requirement calculation, we have converted left to right, right? In number of host calculation, right to left. Like in this direction, it will be calculated. Okay, just a minute. Right here. So number of host requirement, like how to convert the bits means right to left. Example, here power value is what? 4, right? Means 4 bits, 4 host bits need to leave. Leave the 4 host bits, remaining all need to convert. If power value is
Hello?
3, yeah.
How did you get this 4 and what is this 4 from? I did not understand.
See, my requirement is what? How many IP addresses I need?
12.
12 IP address. So what's the formula? 2 power h minus 2 greater than or equal to requirement. So my requirement is 12. Like this value, 2 power h minus 2 value should be greater than or should be equal to your 12.
Okay.
So then if I use 2 power 3 minus 2, 2 power 3 is what? 8 minus 2, I'll get 6.
Fine.
But my requirement is
Yeah.
what? 12. So that
I
this
got it.
value should be greater than or should be equal to.
Yeah, I was not a part actually. I got a call, so I was.
Okay,
Thank
okay.
you.
Yeah. So then if we use 4, then we'll get 16 minus 2, 14 we got. So our requirement is 12, we'll get 14. Out of 14, you can use 12 IP addresses. But now how the convert bits, like zero host bits and network bits means, your power value is 4. Then we have to leave 4 host bits and remaining all into convert. If power value is 3, then leave the 3 bits, remaining all into convert. If power value is 2, so leave 2 bits, remaining all convert. If power value is 6, then leave 6 bits and remember to convert. Like this in host conversation actually, host requirement. So in this example, power value is 4. I'm just leaving 4 host bits and remaining all bits are being converted. So 4 bits are converted. The first 4 bits 128, 64, 32 and 16. Right? So 255 dot 255 dot what's the customized subnet mask?
240.
240 is CSM customized subnet mask. Okay. Let's see how many subnets we can get. We know how many hosts are available, but how many subnets we'll get now? Simple, 2 power n means network bits. How many network bits are converted?
4.
4 bits. So 2 power 4, 16
Subnets.
subnets. So for each subnet, 14 IPs are available. The network ID, broadcast ID ranges.
192.168.0.
Yeah, our base subnet is what?
Not 0.
First one is 192.168.10.0. So what is the magic figure here? Which is the least converted bit, 16 is the magic figure. So 192.168.10.16. So again, 16 plus 16, 192.168.16. Sorry, 10 dot plus 16 is what?
32.
32. Again plus, you keep on adding like 16 times. Like 192, 168 dot, 10 dot plus 16, 48, like this. So broadcast ID,
250. For first one is
192, 168 dot,
47. Sorry,
10 dot, 63 you'll get, right?
53.
For 48, if you add 16 again, it's 64. Before that is 63. So 192, 168, 10 dot, 47. 10 dot 31 92.168 dot 10 dot 15. Like what will be the last subnet range? 10 dot 240.
40.
192.168.10.255. So it's a first subnet range. It's second subnet. It's third subnet. The fourth subnet. Like between we have, and finally last one is a 16th subnet. These all are network IDs and broadcast IDs. So like we can do based upon host requirement also. It's clear? Let me consider this is a first step. It's a second. It's a third step. The fourth one. Clear? Right. We'll do one thing. I will give one task for you. You try to do the calculation. Same example. Number of host requirement 2 power h minus 2 greater than or equal to requirement. So Office ABC requirement is 2 IP addresses. Try to do this calculation. Based upon number of host requirement. Your task is Office ABC requirement is 2 host. The base example is 92.168.6.0. Do it fast. Requirement is 2. Yes, please.
2 power 2.
2 power h minus 2. Requirement is 2. Then 2 power 2 minus 2.
2.
So 4 minus 2.
4 minus 2.
Yeah, exactly. We'll get 2. Our requirement is
2
2.
host.
Then
Yeah.
exactly we'll get 2 IP address. 2 valid
Host valid.
host per subnet. 1, 2, 3, 4, 5, 6, 7, 8. And power value is 2. The leave 2 host bits. Remaining all need to be converted. 3, 4, 5, 6.
6.
128, 64, 32, 16, 8, 4. So what is the customized subnet mask?
252.
55.
255 dot 255 dot 255 dot
252.
252 is a customized subnet mask. And how many subnets will get? 2 power n. How many network bits are converted? 6 are converted. 2 power 6. 64.
Minus 2.
Subnets.
No minus 2 here. Minus 2 in host calculation. This is
Yeah.
subnets, right? So 64 subnets. What is the ranges? How can I write the ranges? What is the magic figure here? Magic number is what?
4.
4. So 192.168 6.0 192.168.6.4
4.
192.168 6.8 to 168 6.12 like this. Write the broadcast IDs.
3. 11. This
6.15 6.11 6.7 6.3. What is the last subnet range? 6.252
255.
255. So the first
But
subnet
Bali wants
range.
to know that. Hello? Hello?
Hello? Hello, Shiva?
Maybe his call disconnected.
I think the audio is disconnected.
Everybody is there?
Yeah, Madhu, we are there. I think that problem with volume.
Oh, okay.
With this example that you were telling, 192.168.6.0, after that, how he came to 166.4? What is the meaning? The 64 subnets are divided into how many IPs?
No, that's what. So first of all, now we are coming from host to network now. So now, when you are coming from the host, now we have decided that two hosts are there, correct? So the now network ID is will be the least number from the network.
You can
Yeah,
see
the
first
second
step is
maybe
2 power
the
2,
second
4 host is there, right? Like that.
oh, okay.
Is
Okay,
taken.
okay, thank you. Then
Yeah.
done. Okay.
Hear me?
Yeah.
Here.
Who is that?
From here.
Yes, it's breaking.
Yeah, actually, I have login to wire. So powered off here. Hello.
Okay. Yeah, now it's
So can you
clear.
please inform session like from my side like power issues is there? Uh, we'll stop the meeting now. We'll end the meeting now today, and the reminder will continue on Monday.
Okay.
Okay.
The recording will be there, right, Palo? Recording will be there, right?
Yes, no issues.
Okay.
We'll share the recording is
Okay.
on your level update.
Okay, thank you.
Okay.
Yesterday recorded. Okay, ball. Okay.
Srinivas.
Yeah, yes, got it. Hello. Can I start the recording? Hello. I didn't get you, Balu.